Classification of real numbers. So in this lecture, what I'm going to do is I'm going to take each and every number that you or I could possibly think of, no matter how unique that number is or how original that number is, and we're going to be classifying that number in a certain way, meaning we're going to be giving it some sort of label, or we're going to be putting it in some sort of group of very similar numbers. So at this time, I'd like you to pause the video and I'd like you to write down the most creative number that you can possibly think of. And then after we go through the next slide, after I classify every number, then I want you to try and figure out what group or what label that number has. So at this point in front of you, all you see is this big box here. And the way these classifications work are a lot like the Russian dolls, which are those dolls that are stacked inside other dolls. So basically we have a big box or a big Russian doll here. We're going to label it in some sort of way, and then we're going to break it apart and give the inside certain labels. So this is basically a big stack of Russian dolls. What the biggest box, the red box in this case, represents is it represents all real numbers. Now, you also see this symbol that goes with it. Well, mathematicians, they get tired of writing complete sentences like all real numbers, so they've given almost every one of these numbers a certain symbol to help classify it. So this is a different math notation, so the way of writing things that we've seen before. This symbol here is called the double bar R. So if you want to draw this by hand, you draw two bars and then an R connecting those two bars. So this double bar R stands for all real numbers. Now, what are all real numbers exactly? All real numbers are any number that can be represented on the number line. So I'm guessing that almost all of the numbers that you guys picked individually fits into this box here. There's only one type of number that doesn't fit into this box, and those numbers are imaginary numbers. Now, if you've never heard of imaginary numbers before, that is perfectly fine. That is something that we're going to learn way later in the semester. If you do know what imaginary numbers are, just note that we won't be dealing with them at this time, and those are the only numbers that don't fit inside this red box here. So every number that we have thought of at this point is going to fit inside this big red box. So what we're going to do now is we're going to take our largest Russian doll apart and we're going to break it down into two smaller dolls. So you can see here I have a bigger box than the other. Well, that's because the bigger box is going to contain more numbers. So let's start with that one first. The bigger oranger box stands for rational numbers. And you can see the symbol that goes with that is the double bar Q right here. The way I draw this symbol by hand is I make a capital Q and then I put an extra bar that goes with it. Now, it seems weird, why would we use Q to represent rational numbers? Well, we can't use R because we've already used R up here for real numbers. So we have to pick a different letter. Now, don't ask me why they picked Q, but that's the one that somebody picked, and so that's what we're going with. Something that I want to point out now is that people get that double bar R confused. Does it stand for real numbers or does it stand for rational numbers, which I can understand because they both start with R. So let's try and get this straightened out now, so if you see that R later on throughout the semester, you pick the right group that goes with it. Just note that the R stands for the largest group possible, and Q stands for rational numbers. So we need to define what are rational numbers. Well, rational numbers are any number that can be written as a fraction. So whenever you hear the word rational numbers, you should immediately think of the word fractions. But that is a little bit misleading because not only fractions fit into this group. Anything that can be written as a fraction fit into this group. So some examples of that are fractions, of course, themselves, whole numbers, and decimals that terminate and decimals that repeat. So let me give you specific examples of each of these. So fractions, that can be simple as the fraction 3/4. Whole numbers fit into this group because I can take any whole number and divide it by 1. Therefore, it can be written as a fraction itself. Now, we don't see it typically written that way, but that's how we know that it fits into this group. And also decimals that terminate, something like 4.32. This decimal ends, so that fits in there. And decimals that repeat, so something like 8.676767, so on and so forth. Anything that can be written with that overline symbol. So most of the time we're not going to see it written like this. Most of the time we'll see it as 8.67 with the overline symbol, meaning both the 6 and the 7, that set of digits, keeps repeating. So all of these numbers that I've written here are examples of numbers that fit into the rational group because they all can be written as fractions. So if that's all that fits inside this group, what doesn't fit inside the group? And more importantly, what is the name of it? Well, if it's not rational, that means it has to be irrational. Now, the symbol that this book that I'm referencing uses is the double bar H. I've also seen other books use the double bar I, basically a capital I with 2 lines through it, and there might even be other symbols out there. So this group does not have a universal symbol that goes with it. But I wanted you to be familiar with the H because you will see examples of that on your homework. Well, what type of numbers fit into this group? Well, the easy answer to that question is all of the numbers that aren't in the rational group. And the only thing that we have left with out of that group is decimals that don't terminate and they don't repeat, meaning they go on and on forever in a non-repeating type of way. So I can give you some examples of this. The easiest example is pi, because pi is approximately 3.14159, and it continues on and on forever, meaning it doesn't stop and it doesn't repeat. Other examples of this are something like 5.0, 500, 5000, 5000, and I think you get the point. Now, this looks like it may be a repeating decimal, but I cannot write this with the overline symbol. It's not the same block of digits that goes over and over. So it has a pattern, but it's not a repeating decimal. But actually, most of the numbers that fit into this group are square roots or cube roots or any type of roots that don't simplify evenly. So an example of that might be square root of 19, because there is no number times itself exactly twice to give me 19. But be careful, not all roots fit into the irrational group. If your square roots or cube roots or any other roots come out evenly, then that means it goes into the rational group or the Q group. So an example like cube root of 64 would go into the rational group because that simplifies to be 4 evenly. So if it comes out to be a whole number, then it fits into the rational group. If it comes out to be something in between, then that means it goes into the irrational group. So hopefully at this point I've clarified what rational numbers are and what irrational numbers are. So I guess that means it's time to split our Russian dolls down apart again, or split our math boxes into smaller groups. So we split our rational numbers into smaller groups. So we're going to look how we can take those rational numbers or fractions and see how we can divide them into smaller groups yet. Well, first we take off the fraction part of it, meaning all fractions, all decimals that stop, and all decimals that repeat go into this smaller group here. So hopefully you're asking yourself at this point, well, what is left over to fit inside this bigger green box? And probably the answer to your own question is whole numbers. But be very careful because we don't actually use the vocabulary word whole numbers here because that means something different. The word that we're going to use here is integers. And the symbol that goes with this is a double bar Z. So hopefully you're getting the point that all of these are a double bar type of letter. The way that I draw this by hand is I make a 7 and then I connect that with a capital L. That's how I usually draw it. Or I've seen other people just draw it as a Z with an extra line through it. And both of those are perfectly fine. So what Z stands for is integers. And it basically means the same thing that you probably thought of earlier, whole numbers. But we have to be more specific. These whole numbers can be either positive or negative. So integer stands for all positive and all negative whole numbers, meaning 0, 1, 2, 3 going up, and -1, -2, -3 going down forever in both directions. So if you were to draw a number line, these were probably the numbers that you would draw first on your number line, all the integers. So we need to break this box down yet again. So we're going to take off the negative part of these numbers. So let me scratch out the negative part of these numbers. And that leaves us with this list over here. So that leaves us with what are now officially called the whole numbers. So whole numbers do not include the negative numbers. That's what is labeled by integers. So integers is both positive and negative. Whole numbers is just 0 and on up. And as you can see, I've listed that there. And we have yet to break this down one more time. So we're going to put 0 in its own group, which means we're left with our last labeling or our last classification of numbers. And the label that goes with this is the double bar N or natural numbers. Now, the reason that this is called natural numbers is because these are the numbers that are most natural to us. So I'm guessing when I asked you to come up with your most creative number, I'm guessing that most of you actually came up with a natural number, and that's completely understandable. So what are these exactly? Another label that we could use for them is the counting number. And of course they are +1, +2, +3, so on and so forth. When we teach our toddlers about numbers, we teach them to start counting with 1, 2, 3. So it's perfectly understandable that these are the numbers that are most natural to us, or natural numbers. Now the last thing I need to warn you about is each number that you've possibly thought of can have more than one label. So just because it fits into one of these boxes doesn't mean it only has one label. If it fits in a box which is in another box, it actually has all of those labels. So, for example, if the number that you thought of was 37, that number is classified as a natural number. It's also classified as a whole number, as an integer, as a rational number, and as a real number. So it has all of those different labels that goes with it. So each number can have more than one classification or more than one label. This is where I'm going to stop this video. In the next video, I'm going to be working specific examples that you will probably encounter in your online homework, and hopefully that video of examples will help clarify any confusion that you may have with this at this time.